attendees are in listen-only mode.
Good afternoon all. Thanks for taking the time out of your day to come join me, Bill Brayton, ATRA Senior Research Technician, for a internal look at the 761, 960, and AB60E. Okay, today's sponsors by Seal Aftermarket Products, your source for engineering solutions.
Seal Aftermarket Products engineers and manufactures Toledo Transkit, the most trusted and complete kits in the industry for 25 years. Toledo Transkit gives you more critical components, more OE components, like premium seals and gaskets, more design enhancements, patented components, and all the little extras you won't find elsewhere. At Seal Aftermarket Products, we don't just make kits, we make kits better. Toledo Transkit is the #1 choice of installers because of all the intensive research and development that goes into each component in every kit. Like re-engineered valve body gaskets, preventing EPC damage by eliminating the shredding you get from original equipment. Plus, all of the extra essentials that are included, like spring and screen filters that should be changed at overhaul. Toledo Transkit even includes loose valve body gaskets that fit all 19 bonded separator plates. When servicing Honda and ATRA transmissions, shaft nuts are quite often damaged during removal. Toledo Transkit provides all the main shaft, secondary shaft, and counter shaft nuts, so you don't have to try to reuse the originals or pay extra for them at the dealer. Honda ATRA kits also include valve body screen filters, pressure tap washers, and other important components like bolt locks, roll pins, and pistons. What you get is a complete kit with great fit and no wasted time or worry about ordering extra parts. If you want the best sealing transmission kit in the industry, ask for Toledo Transkit by name.
All right, moving right along. If you have, as usual, if you have any questions or comments, please send those to webinars@atra.com, or if you have any questions during today's presentation, feel free to hit the questions tab and type in your question or comment, and we'll address that and see if we can get you an answer. Also, there may be some changes. There's, I know, at least one change in our show today. And if you want to save that change, you can hit the camera icon on your screen, and that'll send a JPEG to your desktop so you can refer back to it later. We're just about midway through the year here and midway through our webinar series. Next up is my final for the year, the 845 RE. And then my colleagues are going to take over for the balance of the year, and a lot of presentations on a lot of great info. So thank you for hanging out with us on your lunch, and we'll see you in Vegas in October. Save the date, 19th through the 22nd. Same place it was last year. Been at the Paris. Is a real nice location. It's a bigger showroom floor. So really, if there's one trip that you take this year, that'd be great to see you in Las Vegas. So today we're going to take a look at the internal components and some of the differences, and how to identify the different components, and also throw you in some stuff that might not be in your book. It's very critical to have a complete apply chart as to what goes in where, because the transmissions are different and they only fit certain applications. So you want to make sure that you get the right unit for the right vehicle. Here's a cross section of the components we'll be talking about today, except with the converter excluded. We won't be talking about the converter, but the rest of the clutches and brakes that make up the unit. It's a nice cross section that we have. And here's our first correction of the day. When I was going through this supply chart, I noticed that there wasn't a change. If you look at your handout on the 1 to 2 shift, it does not have the B3 applied in second gear, which is the change that it makes from the 1 to 2 transition. Besides some Spraggs coming on, the B3 clutch comes on. The rest of the applied chart is accurate, so this will be changed in the handout that gets ultimately put up on the up on our website. Or if you want to take a screenshot of that and save it with your handout, please do so. Here's the different ratios. They're not all the same. I mean, we start you know, with the 761, 960, of course, the AB has got a lower, the 960 has the lowest and smallest engine. So we want to look at that and refer back to that in case we have ratio codes. Here's our solenoid firing chart. If you have erratic shifts, this is what you're going to, this is where I would send you. If you have erratic shifts, my first question would be, what are the solenoids being commanded to do? And you get this chart out and watch the commands to be sure that we want to determine whether it's a solenoid malfunction or if the computer is not controlling things correctly. Now here is another illustration that's going to go under, that's going to go through a radical change. I did not have time to change this in between the last show and this show, trying to figure out, because here on the right side we want to identify the solenoids correctly, and these obviously when I went through it the first time it said 1, 2, 1, and that's just these numbers are incorrect. And I'm going to be, once I finish with this webinar today, I will be altering this picture so it looks different, because this is A, and I can't write very well. This is shift solenoid B, C, D, and E. That, like I said, it's very hard to write with my mouse. I'm not using a pen here. So then this becomes PCSD. Can I write this way? PC, oh well, no, not going to try that. Never mind. All right, so these are incorrect, and I'm going to change this. This will be changed, this picture will be changed so that these are correct, because you can see down here it was marked number 1 and number 1. These are actually PCS A and B. And then obviously this is lockup control, or TCC. And the reason why this becomes, guys, the reason why this becomes important is when you look at your scan tool is going to say shift solenoid A, B, C, D, and E. And if you don't have this information written down, it's very difficult to find. I spent a lot of time researching what's A, B, and C, and when we have it in these charts, so you know what solenoid to address very quickly. That's the point here. So that'll be changed here by, most likely by the end of the day, if not first thing tomorrow morning anyways. So that chart is going to get corrected. Okay, there again, the next thing when part of your diagnosis, we want to check the fluid. And just like all the other units that's so critical these days is the trans temp. Now, if you don't have a trans temp reading on your scan tool, there's an operation where we can jump over pins 4 and 13 at the DLC, and what that does, it puts it into a temperature check mode. So you go through this, move the shifter back and forth, from neutral to drive, every 1.5 per second, per second, and every 1.5 seconds or 6 seconds, and then it will know it's going into this temperature check mode, and it'll blink the combination meter, comes on for 2 seconds, and that means it's in the mode. And then the shift indicator, once it reaches 115, it'll blink, and then when it goes to over 133, it'll start blinking again. The optimal range is between 102 and 120 degrees Fahrenheit. And then we use a fill plug and an overflow standpipe, just like we come to know and love. One note about fluid, you know how I am. If it says to use ATF, if it says to use ATF WS from Toyota, you ask me what kind of fluid I can use because I don't want to pay $10 a quart, I will say nothing. That doesn't mean I won't say anything. I will tell you that nothing substitutes for the factory recommended fluid. In spite of what you may have done in the past and you say that it works, well, these fluids are designed specifically to work for this operational system. So that's why here at ATRA we will always tell you that it takes factory fluid. This is just a cartoon drawing of what we're going to see here in a minute. Here's our fill locations. They're all the same between the 3 models. Here's a view of the standpipes. The standpipes. Yeah, that's not going to come up very well with the ink. And the fill plugs. We're going to see here in the next a little bit different view. A side view of what the standpipes look like. Do not overfill. Bad things happen when we overfill. Always change the washers. That's such a simple thing that's overlooked that can prevent a leak. Just know that they vary from unit to unit. One might have a rubber gasket with one style of filter. The other might have a fiber gasket or a paper gasket with another style of filter. Of course, when you call and ask us about shifting concerns, we're going to ask you things like, what's line pressure doing? Because, you know, I'm not in the mountain states when you call me in, and so I haven't had the chance to drive the car. Well, you know, what's line pressure doing? Well, it goes into gear okay. Well, great, but what does line pressure rise do? Well, I don't know. Well, that might be the reason you're having slipping shifts. So we need to get a gauge on there. And a lot of times, and I want to be really clear on this, guys, is a lot of times I don't really care what the numbers are. Of course, I want to see 50 to 60, but when it comes to line pressure rise, I want to know that line pressure rise is happening. You know, if you get 175, you know, I'm not going to quibble about 5 pounds of line pressure, but I just want to know that it exists. So that's very important when you have shifting concerns. Most of the internal components are designed the same. They're just larger than the other. From left to right, the 960, the 760, and the 60, you know, from the small to the large. And it's interesting, they use the 960, the higher number for the lower horsepower, smaller engines. Smaller number, higher horsepower, higher torque rating. So Obviously the 60 being the largest of them all. But the stack-ups, the stack-ups are all the same. They're just different sizes. The drums are designed the same, the Spragg rotation is the same, etc., etc., etc. Okay, so we'll look at that here in just a second. The bell housings is just the difference in engine applications. The middle is the small, the left is the medium, and pretty clear the right is obviously the large. So just an identification setup right there. Another key external identifier between the two is the case connectors. The AB60 has two, and the others have one, which I'll show you in just a second. And you can also see that the AB60 has two temp sensors. One temp sensor is used for pressure control to make sure that it shifts smooth through the temperature ranges, and the other is shift timing control. We may want to stretch the shifts out when it's cold to heat the fluid up a little bit faster, decrease the viscosity, and thus increasing fuel mileage. That's what 99% of the computer stuff is all about these days. We have two holes in the valve body. If you got two valve bodies next to each other, you'll see that if there's only one, that's a 761 960 valve body, and the AB60 has two. So that's a really quick, easy identifier. Here's the 60, the 760 and the 960 side by side. You know, they're virtually identical, with the exception of the height on the case, the 960 being a wee bit shorter than the 760, so you really want to pay attention to that. But basically they both just have one connector and only one hole machined into the valve body casing. If you see it's blocked off and it's never been machined, you know it's a 960 761 valve body. And I believe, and nobody's told me otherwise, that these valve bodies are completely interchangeable. It's the computer that I believe, I may be wrong. Somebody out there can correct me if I'm wrong. But anyways, let's keep going here. We've got a lot of stuff here. Make sure you get your solenoids indexed correctly with the retainer pins. Yeah, I know some good builders that can make those solenoids fit any which way they want to. And the other thing about solenoid placement, unless you have this piece of paper out in front of you, use your cell phone. Take a look at this view right here. What you're going to get out of that, number one, is where the different colored solenoids are. Number two, the direction of the connectors. So such that when you go back together with this thing, you can say, okay, wow, got it back together. It's going to go. It's going to work. Just like when I took it apart. Here we have the small parts for the valve body. One thing about that, you know, Toyota classically has had these square connectors here. And what makes that important is you need to know where they came from. Lay them out. Because a lot of times, and I'll show you here a place where there isn't any pressure on those square retainers, you'll flip the valve body over and you'll just end up on the bench. Or even worse, they may bounce off the bench and into that black hole underneath your bench where parts go to die. They fall into that black hole somewhere underneath the bench and you're never able to find them again. I don't know if your bench has one, but mine had one for all those years. So here's the breakdown of the valve body. And here's where I was mentioning the shuttle ball and sleeves right here, 7, 8, 9. This is one of those locations, and right here where you're going to have those retainers that are going to simply just fall out. You want to make sure that you watch where they go because you're going to end up holding them in with some assembly grease when you go back together. And you know, builders don't like it when I say this, but to prevent problems, you want to take the time to pull every valve out of every bore every time, because the life you save may be your own. All right? Because when you do that, it creates a situation where, number one, you look at the bore. Number two, you look at the valve. You look at the coating and make sure that it's not all scratched up or it's separating from the valve, which is indeed going to cause problems. And despite what some guys may think out there, your pocket screwdriver, you know the one I'm talking about with the magnet on the end of it, is not a rebuilding tool. Your pocket screwdriver just is not a valve body rebuilding tool. So just because you pick a valve doesn't mean you've thoroughly inspected the valve body, because that's one of the things I will ask you if you call in. Did you inspect the valve body? Oh, well, sure I did. I picked the valves and everything works great. Okay, well, that's just not necessarily true. Check ball locations. We even have one here that's not circled right here. You may want to add that to your handout or take a picture of that and set it aside. One thing about Toyota valve bodies is that all the check balls are orificing check balls. There's no, there aren't many bathtubs in Toyota valve bodies. So what that means is that these check balls are orificing check balls. They use these check balls to slow the rate of apply or slow the rate of exhaust of any clutch in the unit. So, and we just know that from over the years of working on Toyotas and seeing their schematics. There's not schematics involved in this. So I can't tell you what each and every one of these little check valves does, but I know that they're orificing check valves. We've got a large hole and a small hole, so that routes the fluid through a smaller or larger hole depending on the calibration of the unit. Here's the small valve body. The critical part here is right here on the accumulator regulator valve lineup. You'll notice it's a little hard to see, but there's an X right here that has been etched into the sleeve, so that when we put it back together, it comes out in the same location that it went back into. You know, builders being builders, myself included, we always want to redesign the mousetrap, because if they thought that was good, well, let's turn it in and give it more pressure. That has to make it better, right? Well, I mean, that's fine for a truck. If you want to improve shift feel, that's fine for a truck, but maybe somebody in their cushy Lexus might not like that. So just beware of making adjustments right there, because that is a place where we can affect the shift feel. More check ball locations, more tab locations up here. You want to be sure that you secure those properly when you're going back together again. This is an accumulator piston. It's not a valve. I noticed that they make these. Pistons in the aftermarket. So check these bores for wear very closely and replace them as needed. And obviously, if the valve body's chewed up, it's going to need to be replaced. Always keep the springs with the piston. whether you use a tag wire, and we'll be looking at more pistons here in a little bit, piece of tag wire or a safe place where you know that those are going to stay together. Here's our line pressure blow-off valve, fairly large check ball with spring. On here is the the rest of our accumulators and their associated springs. Up in the left-hand corner is very important. Spring dimensions and color are model specific, which means that these spring lineups come off of this transmission that we tore apart. I'm not quite sure where this unit came from. I mean, I do know it's a 761, I believe. And these are the spring lineups for this particular model. So I encourage you to take, when you remove, say, the B1 accumulator, you take out the accumulator. You don't have to worry about these top springs. These top springs, these small springs on the right, you see they're in there with retaining clips. So you don't have to worry about those springs going anywhere. But you have to, my recommendation, as soon as you pull this out, you get some tag wire and you tag wire this piston to this spring. This way the spring will follow the piston through the cleanup process. And I would encourage you just to take it over to the solvent tank and wash it off with solvent, pull the seals off and put new seals on it. Just that simple. Because you can't go by this picture for the unit you're working on because your springs might be different. So if you don't wire them together like I'm asking you to, you know, with a builder and the R&R man get in a fight and he walks by and gets pissed off and pulls a rag out from underneath his accumulators, and you call me and ask me what color goes where, you know, I'm going to tell you as best I can, well, this is the lineup I have for my springs. You know, well, I don't have all those colors. Well, the book is not very, the book meaning the OE, the factory, is not very forgiving when it comes by that stuff. So the point here is just be extra careful with these springs. Okay, let's get to the Spraggs. Low and reverse Spragg down in the case. If you get it in incorrectly, just like most of the low and reverse Spraggs we've come to know and love, it might not, your car won't move in drive, but you pull it down into the manual ranges and it will. Be careful when you drive it, because if you should drive it in the manual range, as soon as you shift to second, it will stop the car. It'll either break the Spragg or you better be wearing your seatbelts. Here's the F1 Spragg. Unfortunately, they did not, for whatever reason, decide to number the Spraggs back to front. One thing we want to point out is be sure when you put this aluminum housing in that you align the holes, the feed holes will go right about in this area right here. And when we put it back together, the tabs facing, that there's a notch in these tabs. And they need to, the notch, it's difficult to see in these pictures, but there's notches in these tabs. Tabs must face up. Okay. Here's the F2 Spragg. If it's installed wrong, it's like an intermediate Spragg. You get no second gear. And it may bind up on the 2-3 shift. I was just speaking with a friend of mine that there's very specific notches in both of these washers that if you do not get these seated properly, because once you get this settled down in there, if this washer, either one of these washers are not indexed correctly, you will not be able to get the pump in. The pump will go down and in there, but the unit will lock up. So be very careful with tabbing these thrust washers into the proper location. Here's the F4 Spragg and the C4 and C1 clutch hubs. This is basically a forward Spragg. This is a forward Spragg, and this is where the coast clutch splines up, much like a 700 4L60E. Here's the stack up. Now, on the C1 and the C4, these things run really tight clutch clearances. 22 for the C1, 22 to 34, and 12 to 24. Those are the factory specs. Also, and here was the little bit of dispute, and one of you guys might have something to say about this. There was a little bit of a dispute. I didn't have time in between the last two webinars to call my parts guy, because one guy said that the molded pistons came in the kit, and there was another person that said they did not. So I can't confirm or deny based on the fact that I've never ordered the kit myself personally, but I will be speaking with my parts supplier. I'm not sure if anybody out there has had that experience. But always replace these pistons. Here's what the stack up looks like with the coast clutch in place, and the forward clutch is getting ready to go in there. And notice both of these pistons, there again, it's like a 4L60E input drum. Both of these pistons push up towards the pressure plates, which might not be a big deal, but it will be once we change up a little bit. The C2, C3 drum. This is part of this splines to the input housing. And there again, we have some close tolerances on the clutches. One assembly note is the notches in the drum in the C2 have to notch in, have to pass through the notches in the outer shell. That's very critical. Although, you know, you'd be surprised, I have some good rebuilder friends that could probably make that fit, but you want to make sure that you align those correctly. Here's what it looks like when it's going together. Okay, like I said previously, the notches must go down in there correctly in order for the snap rings to fit properly. And here's the drum all assembled together. Well, not quite. The picture on the left still doesn't have the snap ring in it. But when you air check this unit, the C2 clutch is going to air check this way. The C3 clutch air checks the opposite way, which is a little bit different, a little bit changed up in the way things have been done, but that's the way they've done it through this whole series, and it's worked quite well. It just makes for kind of a funky air check when you start seeing how it works. And always put it on the pump, which I will show you here in just a bit. And that goes back to, this applies like a regular clutch drum. Here we have it all put together, and we can see how the C2 applies. This is the breakdown of it, looking down into the drum on the left. And here's the gear train. Excuse me. Okay, we see the Spragg, or the forward clutch drives the intermediate shaft. The C2 drives the middle planet. That's critical. We'll get back to there in a minute. The C3 hub drives the sun gear. The B3 holds the F2 Spragg, which will hold the sun gear from rotating. The F1 Spragg is splined to the front planet to keep it from rotating. And here we have the middle planet. Middle planet ring gear is right here. And what's important about that, and let's look at this right here. We have the C2 driving the middle planet right here. And if you remember from our power flow conversations, there's a planetary rule that cannot be broken that says anytime the planet is the driving member, anytime the planet is the input to the planetary gear set, the output will always be overdrive. So when we think about our power flow, and I'm going to talk about that more in just a second, we can see that, oh look, the C2 drives the middle planet. So the middle planet at some time when overdrive starts happening, that's the major player of our overdrive ratios. Here's the rest of our planetary gear set. We've got the intermediate shaft, and I can tell you from the 6 speeds, and the 8 speed, this intermediate shaft is splined right here to the forward clutch, and when that's driving this sun gear, it drives this planetary for a low gear ratio. That's part of the power flow. But like I said, I'm going to talk more about that in just a second. So here's the output shaft shims set up. The lip always faces towards the case. Make sure that you set the spacers and the shims aside. It's going to help with our end play. Here's our air pump locations when we set the 1, 2, 3, 4 clutches onto the pump. This is where we're going to air check them. And this is where we're going to air check the rest of the transmission. Here's a short note here. When assembling the unit, always make sure this anti-rattle clip is in the correct location. And lastly, we're just about done today. You have a few more minutes of your lunch left. If you open up the PDF and copy and paste this URL to your browser, this brings up an awesome video that from my friend John Kelly at Weber University in Utah. It shows the power. If he goes through the 6 speeds and how the clutches apply and how it gets the ratios that it does. I can't cover it in the time space. I'd have to do a completely different webinar to do this. So yeah, take a minute, go watch this at John Kelly at his YouTube channel. Really fantastic video on how it gets the ratios and the rotation and how the Spraggs are all working. All right, guys, that concludes our presentation for today. Are there any questions while I'm talking about closing here? Feel free to type any question you may have. Otherwise than that, my name is Bill Brayton. On behalf of ATRA, I wanted to wish you a pleasant day and go out there and make some money, and we'll talk to you soon. Have a great day. Thank you, Billy.